speaker is Dr. Matt Ajemian. He's going to tell us today about Rigs-to-Reef in the Western Gulf of Mexico, sampling considerations, fisheries impacts, and design recommendations. So Matt,
all right,
whenever you're ready.
Thanks, Greg. Well, this is a talk to wrap up a lot of the work I did in the Western Gulf of Mexico, actually with Greg and his fantastic group. I want to recognize a few of our co-authors. Matt Strike, a lot of this is, well, part of this is his dissertation work. Jen Wetz, Rachel Bruton. So they all contributed to this in some fashion. If you weren't here for Matt Strike's talk, a few talks ahead of us, this is the process of taking decommissioned oil and gas platforms and converting them into reefs. This is something you can do in the Gulf of Mexico. The states have permitted reefing areas that the platform supports or jackets, that's what you're seeing in the back here, can be donated to and either reefed and placed or dragged to a certain zone. This was a map of our survey area along the central Texas coast. So every single red star you see there, okay. Every single, one more time. Every single red star you see here is a permitted artificial reef site. So within each of those, there might be several structures. Decommissioned platforms are the primary structure, but there were some ship reefs closer to shore. And we had a pretty wide array of sites, stemming all the way out to about 90 meters depth, starting at about 30 meters of depth. And over time, we really kind of got ourselves involved with three big projects, all kind of interrelated. The first was really how to sample these really large and complex structures. So decommissioned oil and platform materials are really large and they're really complex. So they're porous. They have lots of areas to hang your gear on, and they span quite a vertical extent as well as horizontal extent. So trying to develop methods to survey those structures in a standardized way was the beginning of all of this work. And then we moved into characterization of the species that were actually inhabiting the structures. And given that array of sites that kind of stretched over and across the shelf a bit, we were able to look a little bit at ambient environmental conditions and how that might affect the types of assemblages of fish species you might be seeing. We then got some funding from the NOAA Marfin program in 2013 to really start looking at how are these fish performing on these different sites. So we took red snapper, given the interest both commercially and recreationally, and took a really hard, in-depth look at that. So I'm going to just give you a couple of pieces of this first project, which was trying to understand how to sample these really large and complex structures. And there were methods developed over the years by Stanley and Wilson et al., who did quite a bit of ROV work and also active acoustics work on standing platforms. But certainly we wanted to replicate that a little bit because we were very much interested, as they were, in how do fish communities and composition change as we go from the top to the bottom of these reefs, and where were the fish really just hanging out. So we took some components of their work, which involved a depth interval transect, and using a micro ROV, or remotely operated vehicle, we approached these structures with these kind of 1-minute stops every 5 to 10 meters to get an understanding, again, of the vertical structure of the water column in terms of fish communities. The ROV we used was a Video Array Pro 4, and this is a very popular item on the market right now, or it's been a popular item for several years. It's a great little device, but it's certainly susceptible to currents, being a micro ROV. So we did have to restrict our surveys looking up current for the most part. And as Matt Strike told us earlier, the nephloid layer, which is a layer of resuspended sediment that's pretty persistent in the central and south Texas area, certainly affected our ability to survey red snapper in particular, who like to hang out towards the bottom. So we did have to take in some complementary approaches over time. We did also implement roving transects, and Matt talked about this a little bit earlier. because we knew that this had the advantage of being able to encounter the variety of species that were out there. So we did do horizontal roving transects where possible, particularly at the top of the structure as well as the bottom if possible. So this is a graph showing you a lot of things. So what we're looking at here is the ROV depth. Okay, and this is along a single survey, about an hour long. And then what I'm plotting in the blue here is a cumulative species plot. So every time we see a new species, it gets added on here. And the idea here is to show you that it is necessary to span the vertical extent of the structure in order to encapsulate the majority of the fish species that are out there. So you see in this particular dive, around 36 minutes, we reached about 80% of the species that we could identify over a course of an hour. So we did try and use this information to guide our other surveys because we had 15 sites, and some of those sites had as many as 12 structures. So it was required for us to develop an assessment protocol that was rapid. So we used this information to help us out. We also looked at, again, the vertical structuring of fish density, and this is showing you here proportional structure depth. So 0 is basically the top of the structure, and here's a partially removed or a standing platform and a topple platform. So you can kind of see a little bit here some of the differences between the two types of structures. So you tend to get a bulge in fish densities right at that interface, and as you get lower, it trails off on a partially removed platform. But with toppled platform jackets, you tend to see the greatest densities of fish right along the bottom. So this was very instructive for us kind of moving forward. So again, once we figured out how to sample these reefs, we wanted to really learn more about what was using them. So I'm showing you a video here of a toppled platform. So this is PN967. This is also the video that Matt Strike showed 2 talks ago, but mine's going to be more descriptive. So here we've got a toppled platform structure, and we're looking at essentially the old walkway of one of these artificial reefs. So you see a variety of species kind of all over the place. And coming into view here, this is a Goliath grouper, and we hadn't seen these in years. This is a TED off of a trawl net. So you do see a lot of gear that gets hung into these structures, and kind of emphasizes the point that a lot of people didn't really kind of know where these were, or they knew where they were, and they got a little too close. So overall, we documented over 60 species coming from about 20 families. And the Rigs-to-Reefs site supported a variety of commercially and recreationally important species, obviously red snapper, but great triggerfish, a variety of jacks, and groupers such as scamp were very popular. And I also want to bring up the point that, these structures aren't just supporting reef fishes, but also very large mobile predators such as these sandbar sharks that we saw in probably half of our surveys. Other types of mobile species like cobia were pretty present around those structures, and obviously lionfish as well. So some of our surveys uncovered some of the early settlement of some lionfish in the Western Gulf, which have since become much more common on these structures since we began surveying in 2012. So one of our goals was to look at this community composition statistically. So you're seeing a non-metric multi-dimensional scaling plot. If you haven't seen one of these before, basically the closer these points are, the more related the species composition. So from the get-go, you see kind of these blue structures. These are actually ship reefs. They're not Rigs-to-Reefs materials, kind of pulling away from the rest. We did get to survey a few standing platforms and, again, toppled structures and cutoff structures, which you see a bit of overlap in those. But when you run statistical analysis, you do find that there were differences among those structure types and even within Rigs-to-Reef structures. So this is kind of a pictorial view of some of those differences. So when you take the standing platform and remove the top, and you have what this partial removal or cutoff platform is, you do actually retain quite a bit of the species. You lose some of this community up here. These are chubs, surgeon fishes, and damselfishes that are much higher abundance on standing platforms, and as one would suspect, given the proximity of that habitat to sunlight and the photic zone. So more intense herbivore densities you see on those standing platforms. But the key is, as you move down lower and lower into the water column, you do tend to lose some of those features. But fortunately enough, a lot of those demersal and important commercial fishes, particularly red snappers and amberjacks, are retained on all those structure types. So at least within the habitats that we were looking at, we didn't see major differences among those rigs-to-reefs options. So I mentioned earlier another aspect of this was having a look at whether assemblage differences were correlated with any site characteristics. So we had sites that had anywhere between 1 and 12 structures, and then spread across an array across the shelf from 30 to 90 meters in depth. And what we found was when we did a relate test, which is basically trying to look at whether there was any correlation between these site characteristics and the biological assemblage that we saw, there was a significant correlation. And then we ran a biota environment matching test to tell us what factors were driving that correlation. And you see ambient depth basically alone was able to explain a lot of that. And more descriptively or specifically, we really saw a difference in the communities once we approached about the 60-meter depth zone. So you see adjacent to these survey sites is the ambient depth, and you can kind of see most of the numbers here above 60 meters and below 60 meters here. So what's going on at that interface? Well, Benny Galloway actually in 1981, which is when I was actually born, so he's been doing this quite much longer than I, he determined that there were 3 different zones essentially along the western Gulf of Mexico shelf in terms of fish communities. So he identified this coastal zone, an offshore zone, and really the 60-meter area is where things transition into this blue water zone and get highly dominated by more tropical species. So I think some of our findings, at least on the rigs-to-reef structures, tends to support that work. So last but not least, some of our work was really aimed at trying to understand how are these rigs-to-reef structures going to affect species like red snapper? What kind of performance are they going to have? And with this, we looked at a variety of metrics: abundance, size structure, age and growth, trophic ecology via stable isotopes, and reproductive condition of red snapper. And to do this, we had to collect animals, and we had to use sites that were relatively comparable. So you kind of saw how the ambient depth can really affect some of that, some of the at least fish community composition. So of the array of artificial reef sites and standing platforms, which are in black, and natural banks, we found a zone where we kind of had representation of all 3 species. And in that zone, we collected fish via vertical longline. So Matt mentioned this earlier, but this followed the CMAP vertical line protocol. We did sets of 10 hooks, 3 different hook sizes, and replicated this 3 times at all these sites. So when you look at catch per unit effort, we did find that these fully erect platforms and artificial rigs-to-reef platforms is what we're going to be referring to as artificial here, and natural banks had similar densities of fish. But we did notice that there are potential issues with the gear due to saturation. So, and as Matt pointed out earlier, based on some ROV data between natural and artificial or rigs-to-reef structures, we do see significant density differences based on optics. One thing we did see, though, were significant differences in length frequency. And really, the standing platforms and rigs-to-reefs or artificial reef materials have very similar length frequencies of fish, but natural banks certainly are harboring significantly larger fish. And as one would expect, these fish are also significantly older. However, despite all that, if you look at length at age as well as weight at age, you do see the artificial reefs, which are these long dashed lines here, they tend to break apart from fish from both natural banks and standing platforms. So the fish at those sites are growing faster or they're at a larger size for those given ages, which we show here as basically beyond 6 years. We also took a look at trophic ecology, and what I'm showing you here is data from carbon-13 and nitrogen-15. And we didn't see major effects, but certainly subtle effects. So for 2 size classes of red snapper we looked at, we found fish on standing platforms were significantly more enriched in N15 and also less depleted in carbon-13. So some of the gut content work tends to suggest that fish at the standing platforms are feeding on more pelagic sources of food. So that might be causing that. We're still doing some final analyses on that right now. And then finally, having a look at reproductive condition, one of our students, Downey, did some of this work, and he took an assessment of the gonads and looked at did some histology and tried to figure out what proportion of fish were spawning capable versus developing. And despite this decrease, as you get down to Rigs-to-Reefs materials in the number of spawning capable fish, this was found not to be significant. We also found similar gonadosomatic indices across all those habitat types as well. So to try and wrap it up here, certainly Rigs-to-Reefs options will influence the fish community, but really you have to take into account what the ambient bottom depth is. And that may even override some of those options. And unfortunately, as many of us are experiencing, we don't have quite the amount of replication we would love to have in those materials and across the shelf. So there are some limitations there. But overall, red snapper performance seems to be high at Rigs-to-Reef structures and comparable to some of the adjacent natural bank habitats. But certainly higher proportions of large fish on those natural banks. And this may be due to the space use requirements of larger red snapper. Matt Strike showed a figure earlier that showed some of the differences in the dimensions of these structures, which are orders of magnitude greater. So that may be required for these larger red snapper. If we were to recommend anything, I'd say potentially target these vertically extensive reefs at 60 meters. And that 60-meter area, again, is that kind of interface where we see the coastal and blue water zone. So there's high diversity there. Also, we see some of the largest red snapper at 60 meters in that area, and they are spawning capable in that area. And if we think back to the divers, which we haven't really talked much about here, those areas also are characterized by consistently high water clarity that we notice. So divers would have more habitat to interact with in this zone. So this takes a village to pull off this type of work, so I'm very grateful to all the individuals of the Center for Sportfish Science and Conservation Lab and Greg's group. I'd like to thank the Gulf States Marine Fisheries Commission for supporting my travel here, as well as Texas Parks and Wildlife, who we contracted with on much of this work, particularly Brooke Shipley. She's in the crowd here. Schmidt Ocean Institute helped us develop ROV logistics. Noah Marfin supported the red snapper work, and other logistical support from the Hart Institute and where I am now, which is the Harbor Branch Oceanographic Institute. So thank you all, and I'll take any questions if we have time.
Thanks, Matt. We have time for a question or two.
Thanks, Matt. Really appreciate the talk. But my question really is in the second to last slide, where if you were going to make any recommendations, and if you could just clarify for me who you might be making those recommendations to and for what purpose.
Yeah. Well, obviously the folks who are continuing to do the reefing work, so Parks and Wildlife, they ask us for recommendations and based on our knowledge of the fish community. So those folks in particular who deal with the the donated material, that they need to decide where to put it and what permitted zones to work with.
So that pelagic component that you showed popping up in the trophic part, but isn't really surveyed, So in California, there are lots of schooling species, pelagic schooling species that use the upper reaches of the platform. And we haven't gotten to the point yet where we can reef. But there's a concern that once we start doing that we're going to lose that part of the community.
Right.
So, but your data are showing that it's part of the trophic web, but once you lose that component, right?
Well, our data are showing that we're losing, yes, so a portion of the pelagic community, particularly the pelagic herbivores and some planktivores that tend to hang out in the the upper portion of the standing platforms. How that trickles down to the red snapper, I would think that they were somewhat disconnected from that, given that they're more benthic and demersal. But yeah, there are inputs that are getting there. We're just trying to do a better job of figuring out what they are.
All right, well, thanks, Matt. I think we need to move on. I know there's a lot of other questions, but don't forget about our reception we have tonight. Hopefully you can ask, most of these guys will be there. Up next is Mandy Karnaskis, and she's going to